Hi there, my name is Sarah Rentorf-Smith. I'm a researcher in data-driven governance and AI policy. And in this chapter, I'm going to give you a crash course on artificial intelligence, or AI. We're going to talk about what it is, where the field is today, and what lies ahead. And I hope this will serve as a valuable foundation for getting the most out of subsequent chapters, where we begin to look into the opportunities AI offers for achieving the Sustainable Development Goals. So first, what is artificial intelligence? Well, the Oxford Dictionary defines this as the theory and development of computer systems that are able to perform tasks normally requiring human intelligence. Such tasks could be visual perception, speech recognition, decision-making, and translation between languages. And I thought just to make this a little more approachable, we could talk about how these different aspects of intelligence are already being piloted throughout the work of development actors. On the one hand, when we talk about visual perception, UNICEF Innovation is building an AI tool that analyzes high-resolution satellite imagery to map every school in the world. And so what UNICEF expects is that this can allow them to measure vulnerabilities, improve its emergency response, and resilience against natural disasters and crises. And other classification tasks that also leverage computer vision could include a mapping of livestock movements. This could help predict conflict patterns associated with transhumance, or what we also call livestock migration, or changes to human dwellings in the context of disaster to understand where the impact has been most severe. UN Global Pulse, through its lab in Kampala, Uganda, is using insights from public talk radio to provide real-time information on what's happening on the ground in terms of humanitarian assistance. And when we look at decision-making or decision support, UNDP has teamed up with IBM Research to use AI to automate its Rapid Integrated Assessment, the RIA, a tool that helps governments assess the alignment of national development plans with 169 targets of the Sustainable Development Goals. And this is expected to help policymakers quickly identify alignment gaps in order to enable them to better integrate the SDGs into their planning frameworks. So to have a better framework to think about AI, there's a number of these out there. One that I think is helpful is created by John Searle, who's a philosopher back in 1980. And this is a spectrum that runs from weak or narrow forms of AI to strong or general AI. And if we look at the weak end of the spectrum, we can talk about an AI system that acts like it thinks and has a mind. So we could say it simulates human intelligence. To the strong end of the spectrum, which refers to AI systems that can think and actually have a mind. This is forms of AI that emulate human intelligence. So going into these forms of AI in a bit more detail, the most prominent forms of these is machine learning, which most of you will have heard of. And I'm going to talk about sort of three different substrands of this and how they work. One of them is called supervised learning, and this is probably the most prevalent. This is where you take an algorithm or a model which takes a known set of input data, so data that has already been defined. If we're talking about images of animals, images of a cat has been labeled as a cat, and images of dogs have been labeled as such. Those are then paired with known responses to the data, as I mentioned, these categories. And the model is trained to generate reasonable predictions for new data. So if you were to introduce a new data set that didn't have the labels, the idea is that the classifier in the machine would actually correctly generate the outputs, so labeling images of cats and as dogs. Secondly, we can talk about unsupervised learning, and this is a very similar approach to what I just talked about. But here, it's really just letting the computer find hidden patterns or intrinsic structures in input data through a clustering technique. So we don't tell the machine what is what, but rather allow for sort of a more exploratory data analysis to distinguish between different subgroups in the data. And this can be useful where we may not be aware beforehand what exactly we're looking for if we want to learn new things. The third form of machine learning that I think is important to just at least have an introduction to is neural networks or artificial neural networks. And as the name indicates, these are inspired by the human brain. In these networks, each artificial neuron represents a so-called activation function, or a function that you might know from mathematics, such that a particular input generates a certain output. And a neural network then represents a stack of these artificial neurons, where the pattern of activation in one layer affects the pattern of activation in subsequent layers, and there can be multiple layers of these. Where we see this particularly prevalent and effective is in areas such as computer vision, image recognition, as well as natural language processing tasks. But I really want to stress that machine learning is not the only game in town. To indicate this, I want to refer to a 2014 article by Google researchers where they called machine learning the high-interest credit card of technical debt. And this refers to the fact that the better performing a machine learning algorithm is, the more opaque it likely is. And so it leaves users very little understanding of how or why certain results came about. And this obviously is very problematic in the context of development, where a lot of work has been done to promote principles of accountability and inclusion. Another challenge in the development context that I see is that big data is not always available in this space. There are many domains where data just isn't recorded, or where capacities and resources aren't available to collect such big data. And finally, the process of cleaning and probably labeling data where available is actually quite resource intensive and again, may not be available. Therefore, it's worth exploring other strains of artificial intelligence. And one that I would like to propose is probabilistic computing, which has the advantages of working well on medium-sized data that's incomplete and often messy, which we see throughout sort of the public sphere. And I won't be going into a lot of detail to explain this because it's a bit complex, but I'll share more resources that you can study on your own time. Also, I think as we talk about AI, now that we've gotten our feet a bit wet in understanding what it is and how it works, it's just worth taking a step back to really assess where AI technology is today. What is reality and what is hype? And every year, the IT research and consultancy company Gartner publishes a so-called hype cycle. This is a graphical and conceptual representation of the maturity of emerging technologies through 5 phases. And it's worth noting on this graph that the location of machine learning, deep learning, as well as cognitive computing are all squarely located at the so-called peak of inflated expectations. So we're really likely to see changes in coming years where we get probably a more realistic assessment of where AI is going. And for those of you interested in staying up to date on the state of the field, you can either consult this report annually or may also take a look at the annual publication of the so-called AI Index, which is available at aiindex.org. Progress in AI is often measured by the ability of AI systems to beat top-performing people at their own game as a measure of intelligence. And some key milestones here go back to 1997, when IBM's Deep Blue beat reigning world champion in chess, Garry Kasparov. Years later, in 2010, we saw IBM Watson winning at Jeopardy, again against 2 human champions. And finally, in 2016, Google's AlphaGo won at the game of Go over world champion Lee Sedol. What's important to recognize is that the AI techniques used to win these competitions are powerful, but really also limited. If you think about it, the neural nets and heuristic search algorithms in AlphaGo can't understand English, and let alone play Jeopardy. And so as a more general point, the machine learning and neural network techniques behind these achievements tend to work well only when data is cheap, tasks are repeated, rules are explicit, and success, failure obvious. And so when we look at social and economic dynamics, this is actually rarely the case. AI exuberance, however, is really not a new phenomenon. Back in 1960, IBM's computers were branded as giant brains, and there were early fears of machines exceeding and ultimately dominating human intelligence. So what has really changed since then? Because obviously that we have seen changes. On the one hand, we've seen vast developments in modern system software. We've seen 100 to 10,000 times more data and computing power being developed. And calculation also works much better now, in particular statistical calculation, which is what's behind machine learning and artificial neural networks. But what we haven't seen emerge is intelligent algorithms that actually work like the brain. And here, I just want to point out that intelligence, as per the initial definition I shared, is not just about pattern recognition, logic, or search, but it's about modeling the world. And that means to explain and understand what we see, to imagine things that we could see but haven't, to solve problems and plan actions to make those things real, and to build new models as we learn more about the world. So as I promised, I want to just help illustrate the implications of this gap between current AI and genuinely intelligent machines. So let's look at the field that has been heralded as making particularly impressive advances in recent years, which is image captioning. A couple of years ago, a number of big tech industry actors independently announced that they had developed AI technology for image captioning that matched and even exceeded human performance. However, if we look at sort of quite a mischievous experiment that's shared on Twitter by the bot called PicDeskBot, which stands for Picture Description Bot, this uses industry-grade computer vision API to generate image captions. And while the bot does a really decent job at captioning certain themes of images that are prevalent, I guess, across the internet, it also makes quite amusing errors. And so one category of these errors seem to be a result of the algorithm not fully understanding the context within objects are placed. A second type of error seems to be derived from the type of language models the caption bot was trained on. Researchers at MIT have demonstrated that beyond committing just innocent errors that are exposed by the PicDeskBot, industry-grade image recognition technology can also be actually tricked into systematically misclassifying an item. And this is through what's called adversarial models. So what the researchers did is build an algorithm that was able to reliably produce adversarial examples, including a 3D model of a turtle, which was classified as a rifle from every single angle 100% of the time. Such vulnerabilities of intelligent systems are important to be aware of as neural network-based classifiers are increasingly introduced in real-world systems, including in the field of development. So just to sum up what the limitations of machine learning and neural nets are and what we need to be aware of as we start considering implementing these is that on the one hand, they have limited to no capability to abstract from one domain and apply this to another. On the other, performance is contingent on the availability of big data that is clean, complete. It's also relying on task repetition and clear rules, all of which don't always apply in the domain of development. And thirdly, these systems have no common sense, as the Twitter bot PicDeskBot illustrates. Finally, they remain vulnerable to adversarial algorithms, which leads image recognition software to make systematic errors that a human would be very unlikely to make. Overall, before we start introducing AI into new domains, where they're likely to affect vulnerable populations, people who are poor, marginalized, have limited access to services such as education, we really must be aware of the risks and vulnerabilities associated with the technology. Thanks a lot.